Bismillahirrahmanirrahim. Welcome to chemistry for class 9th, and this is lesson for week 5 starting from 4th May to 8th May 2020. Assalamu alaikum. Hope everybody is safe and healthy and are following your lessons regularly and doing your assignments on time. Okay, welcome back to week 5. We're going to start in this chapter with physical states of matter. This is chapter number 5, and we are going to do the initial part of this chapter. We'll discuss the gases section. Basically, this chapter is all about 3 states of matter and their characteristic properties, and we will be dealing with chapter number 5, first half, gases. The subtopics included in this week are typical properties of gases, effect on the volume of a gas by changes in pressure and temperature, Boyle's law, Charles' law. The scheme of lesson is given in front of you that tells you that the total subtopics included are 4. The total number of periods covering are 5 with 3 written assignments and 1 weekend task associated with this lesson. I have divided this lesson into 3 parts. You will be following one by one after one another. Here is the weekly distribution of the tasks. You can see that how weekly your subtopics have been distributed for you people, and the assigned tasks are listed in front of them. There are some additional resources given to you people for extending your learning outcomes, and you can also access these additional resources in a separate section of resource section as well. Here are some lesson objectives of week 5. By the end of this lesson, students will be able to define diffusion, effusion, mobility, compressibility, and density of gases, compare the properties of gases, diffusion and effusion, explain the effect on the volume of a gas by a change in the pressure and temperature, state Boyle's law, explain pressure volume changes in a gas using Boyle's law, describe real-life examples of Boyle's law, state Charles' law, explain temperature volume relationship of a gas using Charles' law, and describe real-life examples of Charles' law. Here are some of the typical properties of gases listed for you people, and among them include diffusion. Diffusion is actually the movement of particles from a region of higher concentration to a region of lower concentration, and this happens by spontaneous movement of molecules. As we know that the gases consist of molecules which are having large intermolecular spaces between them, and they are always in random motion. That makes it possible for these molecules to move from one place to another. As they get some space, they occupy all the available space. So this phenomena in which the particles are moving from higher concentration to lower concentration, for example, if you spray a deodorant or some body spray is opened, some perfume is opened, after some interval, within few minutes, you feel that the fragrance has been spread in the whole room. This is because of the movement of those gas particles from one place to another place, making them to spread evenly throughout the room. This all happens due to the spontaneous movement of or random movement of particles, and it is called as diffusion. Similarly, we have another characteristic properties of gases, that is effusion. Effusion is actually when the escape of molecules takes place one by one from a container, or from one by one through a hole, and without colliding with one another. This is called effusion. For example, if a cycle tire bursts in the molecules of gases, they leave from the tire one by one through that hole, and with the passage of time the whole tire gets flat, and this is all because of effusion. So there is a difference between diffusion and diffusion. In diffusion there is no limit or no boundness of the molecules leaving from a hole, whereas in effusion it is particularly limited when the particles are leaving through a hole, and they are leaving one by one without colliding with one another. So both the properties are different from one another. Then it is pressure. We have pressure is defined as when the molecules or the particles of the gases, they exert force across the walls of the container and with among themselves. This is called as pressure. As pressure is defined as force per unit area, and there are different units for pressure: atm, pascal, mm, g, torr, and you need to practice the unit conversions for pressure as well. We'll be doing it in later slide. Okay. Then there comes compressibility. In compressibility is defined as the property of gases as they have large intermolecular spaces between them. So when they are forced to come close to one another by applying pressure, and they occupy or they are squeezed and they occupy now less volume, they come close to one another, so they can be compressed. The intermolecular forces and the spaces between them can be decreased. This property is called as compressibility, and this helps us to fill in these gases, or like LPG, like CNG in cylinders. This is all because of the compressibility of the gases. Then comes mobility. Mobility is defined as the movement, the random movement of the molecules as the gases particles are far away from one another. They have weak intermolecular forces, so they can move from one place to another without interacting with one another. So this helps us to transport gases through large distances with the help of pipes, with the help of containers, and this is due to the mobility property of gases. Then comes density. Density is defined as the number of particles existing per unit area. As gases have large intermolecular spaces between them, so gases are usually less dense, but the density of the gases can be decreased by applying high pressure and by cooling them down, so that when they are cooled down, the kinetic energy decreases and the molecules come close to one another, and as a result their density increases. All right, let's come to see that how changes in volume and temperature affects the gases. This whole effect is studied under the theory of kinetic molecular theory. Kinetic molecular theory states that the molecules are that the matter is composed of small particles, and the particles possesses kinetic energies, and this kinetic energy is affected by changes in volume, by changes in temperature. So we'll see how this kinetic molecular theory helps us to study the effect of changes in volume and temperature on the gases states.
Gases, unlike liquids and solids, have a lot of empty space between the particles. This makes them compressible because the amount of space between them can be reduced when the volume of their container is reduced. Compressibility is the measure of how much the volume of matter decreases under pressure. Again, gases are easily compressed because of the space between the particles in the gas. At room temperature, the distance between particles of a gas in a closed container is about 10 times the diameter of a particle. That distance can be changed, and there are several factors that affect it. The pressure of a gas can be changed by adding or removing moles of particles, changing the volume of the container, or changing the temperature. Let's see how each of these works. The particles are moving around, hitting surfaces, and creating pressure. When you add more moles of a gas, there are more particles hitting surfaces, and the pressure increases. In this container, the only thing that will change is the volume. When we cut the volume in half, from 1 liter to half a liter, the pressure will double. Temperature is actually a measure of the kinetic energy, or movement, of the particles. When we add heat, we increase the kinetic energy, causing more collisions and raising the pressure. And volume can be explained in relation to the kinetic theory of gases. The pressure exerted by a gas on the walls of a container is due to the collision of its molecules against the wall of the container. Gas pressure can be explained according to the kinetic theory. A gas consists of a large number of molecules that are constantly moving at random with high speeds. These high-speed molecules are constantly colliding with each other and with the walls of the container. Consider the following diagram. Assume that a molecule of mass m, with a velocity v, experiences an elastic collision with the wall of a container. The molecule rebounds with the same speed v, but in the opposite direction. The change of momentum of gas molecule is equal to 2mv. According to Newton's second law of motion, the rate of change of momentum produced by the collisions between the gas molecules and the walls of the containers results in a force which acts on the walls of the containers. The force per unit area on the wall is known as gas pressure. The temperature of a gas depends on the average speed of its molecules. The higher the average speed of its molecules, the higher will be its temperature. When a gas is heated and its temperature rises, the energy it receives is converted to kinetic energy, thereby causing its molecules to move faster. This is because the frequency of collision between the gas molecules and the wall of the container to increase, and therefore causes an increase in the gas pressure. The volume of a gas depends on the average distance moved by its molecules between collisions. The average distance moved by gas molecules between collisions is known as mean free path. When the volume of a fixed mass of gas decreases, the free path of its molecules will also decreases. The decrease in the mean free path caused the frequency of collision between the gas molecules and the wall of the container to increase. Thus, the gas pressure increases.